Welcome and thank you for watching. Today we are going to make a financial backtest, and we're going to do that specifically in Excel. Now, this isn't necessarily just because it's the best backtest in the world, but the point is for you to actually think over some of the specifics that you would take in order to test something in Excel. Because what's the whole point of it, right? The point of it is to see how things according to a specific process have done in the past in order to hopefully predict for the future. And we could talk a lot about, the problems of the data and how you want a certain time period and how steps can be unrealistic, how there can be errors, etc. If you want to look at errors, we have that on another page, our Quantitative Finance Club website. We have that from the last meeting. But here is the backtest as I would do it, and let's go. So, let us start out with good old Yahoo Finance, since they provide free, easy data. What should we use? Let us use the SPXS. You might ask, what is the SPXS? And, good question. It's a 3 times leveraged bear ETF. Boom, 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 boom. Let us do the max, since the max is obviously the best thing on the earth. Applied. Frequency weekly. Apply. Let's download the data. Boom. Just like that. Here we are. Are we in time? We are good. Start. Let us clean this up because we do not need really the high and low, nor do we need the adjust close or the volume. So I'm literally just going to right click and delete these columns. I'm going to keep this brief because I want this to be something you can reference back to. But the essence of this is that we want to be long the S&P 500. How are we going to do that? We are going to short the inverse ETF. So to be long is to be long the positive. Since this is the negative, we're going to be negative the negative, which is equal to a positive. But it's 3 times leveraged, and so we're going to use a portion of the portfolio. And then I'm going to go through all the steps here. To start, we want to make sure that we actually know what is it's happening. So we're going to just calculate the percentage change in this ETF and how every single week, date 11, 17, 18, next one is the 24th, so the open and close in this time period prior to the 24th. So we would take C2 minus B2 all divided by B2 is equal the percent change. And this went up a good deal, so it's going to be positive 14. And then what we're going to do is I'm going to copy it. I'm going to go all the way down, select Shift, Control, arrow all the way up, paste, Control V. Boom. Formula applied all the way down. It's a percentage change. And then I'm coming over a few spaces, just give it some room. And I'll call this column Portfolio. You can just type that in online. Whoop-de-doo, Portfolio. And let's just type in a starting value, let's say $1,000. So what we're going to do is we're going to take this portfolio, and we're going to, and this is where the formula gets a little bit tricky. We're going to say that this next column is equal to the past value of K2. Here's the difference, but it's going to be times. Let's do a parenthesis so we can make sure that we do this right. 1 plus D2. Whoops, that would be an error. I'm just going to say no, and I'm going to go back and I'm going to keep doing what I was doing. Close parenthesis. No. Excel, honestly, when I press enter, is going to sometimes give you some negative feedback like what you just saw. Sometimes the answers are good, sometimes they're not. But, Microsoft tries to do what they do, you just got to make sure you do it right. What we have is K2 times 1 plus D2. What is that actually doing? So if you think about it, what K2 is K2 is the value right over here of the portfolio, and we're going to multiply it, that little cute little symbol, times this together, which this is 1 plus D2. So D2 is the change. So this would mean that, we're basically taking this value and then whatever the change of this is, we're acting as if it had bought all of this and moving according to the same percentage. Now, if we didn't have this 1 plus here, what we would have is we would have D2, which is just equal to, the actual percentage. So basically, we would just take a tiny little percentage of this. So it would act like it's some huge loss. I can enter it now. Boom. $1,000 would become $149 after the very first week. That would be a very sucky strategy, except that it's just an error. So here's what would happen if you plug in the formula correctly. However, we're not going to be long. We're actually going to be short. So what we're going to have to do is we're going to have to actually subtract away this percentage. Boom. So this going up would be bad for us. However, once again, we don't want 100% of this amount to be put short into this. Let's say, 10%. In order to do 10%, we are going to have a few simple steps. One is that we're going to have to add another parenthesis. We're basically having K2 times, actually, technically we can do this out another parenthesis, just to make it less confusing, we'll do that, times 1 minus D2. What we're going to do is we're going to take 0.1, just like 10%, multiply it by these values, and then and this means that, if I just go back and press enter again, let's accept the correction, then it not only would, account for some of the value of the change, but it will only account for 10% of the portfolio, which is why that, basically it took for the change of, 150 down, and only did that up $100 of the portfolio. That made this column equal to that. So what happened to the other 90%? We're going to add it back in. We're going to do that by doing plus, and we're going to do K2 times 0.9, and then boom, we get the value that you saw earlier. Congratulations, you done well. But the difference is that it's only as if 10% had gone in this, and that way 90% is basically in cash, which is a little bit more diversified. So nice. There we go. So now all we do is we're going to copy this, come over here, Control arrow down. Remember the portfolio was in K. Control Shift up. We're going to paste that code, and then boom, we get the portfolio value all the way down here. Now we're going to do a little bit more fancy things. Let me check on time again. Alright, we're good. How can we make this a little more applicable? Because, this is real cute, right? You got this portfolio of 1,000, and then you got this portfolio of 1,500. Well, it went on. Great. But we wanted to be able to actually learn from this, because two numbers really don't mean anything. Because technically this 1,000 right here could go down to basically 0, or go up to basically infinity, and then come back down to 1,500. So what we're going to do is you're going to put your, whatever you call this little thing, the box, over the first 1,000, and Control Shift down. And I like to keep my chart up at the top, so I'm actually going to go from the bottom, Control Shift up. Select this column, and then you let go of Control, just press Shift only, down 1, so it's 1,000. Now I'm going to insert this, and I am going to get one of these recommended charts. Oh, look how cute this is. We made a little bitty chart. Good job. All right, so this little bitty chart right here is of the portfolio value over time. And do we want this to be scalable? I think so. Let's go ahead and make this in logarithmic. So I clicked on this axis. You don't necessarily have to do this. You can just select data, and then you got this logarithmic chart. That's not what I meant to. Let's go to, let's try this again. Format axis. There we go. That's a little better. Come over here. I'm going to press logarithmic scale. And then minimum, let's just go and make it 900. Boom. Maximum, make it 2,000. Boom. And here we go. You got this nice little curve. And so, if you just follow this line here, you can just put your mouse on where you might see a top, 1,177. Where you see a bottom, 1,104. And so you might get an idea of, oh, okay, so this is kind of how it moves, which is, it's honestly a pretty smooth curve. It's pretty nice. Alright. And now what we're going to do is we're going to mix a little bit of interactable data. So instead of this 0.9, we're going to take 1 minus, this is where the other parenthesis was earlier, 1 minus 0.1, which, that's equal to 0.9, right? It's the same. But instead of 0.1, we're going to make a reference to G4. And you have to do this specifically. You put the dollar sign in front of the number and the letter, or else basically it'll shift around whenever you copy and paste the formula. You don't want to do that. And then we're going to make this G4 also. G4. Boom, boom, boom. And I'm going to copy this and paste it all the way down. So what I'm going to do is I'm going to point G4, I'm going to put 0.1. Boom. Same information, right? Same numbers. You see the 95, 15, 61, just in case you're photographing memory. And what this is going to be percentage allocated in this block. And I'm going to go ahead and I'm going to highlight this in red so that you can see basically whenever you're changing this, important stuff's happening. And obviously that's a mistake. 0.2, you get 20% portfolio, there we go. You get 0.3, 0.4, different percentages also the portfolio. I'm going to come over here, just because you're seeing the problem, algorithmic chart is going off the scale. And I'm going to format the axis again. What I'm going to do here, I'll try again. Right click. Boom. Is this, I'm going to say reset. Kapew. Even you could take it off a logarithmic scale and just see, you know, what happens. Let's the chart auto adjust itself. And what you can do is you can watch how this will change around a bit, you know, as you change the allocation. And see if it's at 0.5%, 50% of the portfolio that you're going to put in it, then the top and bottom are going to have much violent numbers compared to any and everything else. Alright, so now what I'm going to do is I'm going to make two other formulas, which are going to make sense. One is going to be max drawdown, and the other is going to be percent return. Max drawdown is going to be a little bit simpler than the other one, so I'm going to do it first, which a little bit of rush on time, so I'm just going to zoom through it and you can go back later and look at this. So this is going to be equal to the max of K2. K2 is going to be, I'm going to lock into to K3 minus K3. I think it's going to be K3 divided by, there we go. And then this is going to be 1 minus. I'm not sure if there's a way for me to explain this, but basically this is just taking the current value compared to the highest past value of this data, right here, and then basically getting, you know, at any one point what's the greatest percentage of an account you could lose. And I can go ahead and just change this to percentage. Ta-da-da, ta-da. And then yearly return is a little bit more of a complicated formula. I'm honestly going to just pray that I can remember how to do this. Alright, so this is going to be equal to K. Let's go see what this is. It's going to be K520. There we go. It's going to be K520 divided by K2 and then this is going to and this is going to be equal to, we're going to raise this to the power of 1 divided by 519 divided by 52. Subtract 1 from all that. Boom. And we get a yearly return of 22%. And there you have it. What we have is a simple back test of how it is a portfolio would perform over the isolated, just a bull market period, just like this in Excel.